Have you ever stopped to think about what happens the exact second someone crosses the edge of a black hole? Science has always avoided this answer, not for lack of curiosity, but out of sheer fear of what it might mean. Inside, time is distorted, light disappears, and the laws of physics simply stop working. This is not fiction. This is being taken seriously by physicists at the world's leading institutions. Stephen Hawking warned, there is something in there that could destroy everything we understand about the universe, or reveal a secret we should never have discovered. But why doesn't anyone talk openly about this? What if we are on the verge of understanding a truth that goes far beyond science? Now I want to know, do you believe there is something beyond destruction, inside a black hole? Or do you think it is an absolute end? Write in the comments. Let's see how far your perception goes. And stay tuned, because what comes next could shake everything you thought you knew about reality. Stephen Hawking didn't just want to understand the universe, he wanted to challenge it. From the earliest years of his career, it was clear that he didn't accept the limits imposed by existing theories. While many physicists were content with the idea that the interior of a black hole would be forever inaccessible, Hawking believed that something fundamental was being overlooked. He didn't see the black hole as a dead end, but as a piece of machinery that could redefine the laws of physics. His obsession began with a simple but vexing question. What happens to information when it enters a black hole? Classical physics suggested that it disappears. This meant that if you threw a book, a star, or even a human being into a black hole, all the data that defined that existence would be erased forever. But for quantum mechanics, this was unacceptable. Quantum theory states that information cannot be destroyed. It can change, but it must always be preserved. Hawking then proposed something radical. Black holes are not completely black. They emit a faint radiation, now known as Hawking radiation. This emission suggests that over time, a black hole can lose mass and eventually disappear. But it raises an even more serious question. What about the information that was inside? Does it evaporate along with the hole? This puts two of the most successful theories in modern physics on a collision course: general relativity, which governs the cosmos on a large scale, and quantum mechanics, which describes the behavior of subatomic particles. This contradiction was called information paradox. For Hawking, this wasn't just a technical problem, it was a threat to the very fabric of physics, and he wouldn't rest until he found an answer. His work laid the foundation for a new generation of studies that seek to unify the fundamental forces of the universe and perhaps reveal what lies beyond the event horizon. But all this research comes to a point where current knowledge simply disintegrates. A limit where space, time, and logic seem to implode into something that science has not yet been able to completely decipher. Inside a black hole, traditional physics stops working, literally. Space bends until it collapses. Time loses its meaning. Everything that enters is compressed into a region of infinite density, the singularity. It is at this point that the most reliable equations in science simply cease to offer answers. Gravity, according to Einstein's relativity, intensifies so much that there is no after and no space to exist. The singularity is not a place where the laws of physics are hard to apply. It's where they fail completely, and that poses a problem. A black hole is not just an exotic object, it is a rupture in our understanding of the universe, a boundary where scientific reason breaks down. The question that arises is straightforward. Is this an error in the model, or a sign that there is something beyond? Some theoretical physicists consider that the singularity may not be an endpoint, but a transition point, a passage. The idea seems extreme, but it makes sense within certain models of quantum physics. If space-time can bend until it collapses completely, why couldn't it also reconnect at another point in the cosmos? or in another universe. It's possible that the singularity is less of a chasm and more of a fold in the fabric of the universe, as if everything that enters it is projected somewhere else, somewhere outside our space-time. This hypothesis raises profound questions. What would it mean, for example, to cross this point? Is it destruction, transformation, or a new beginning? If this is true, the singularity would not be the end of everything. It would be the beginning of an even more complex structure, one that not only escapes known laws, but perhaps replaces them with rules we have not yet been able to decipher. And this leads us to an even deeper conflict. In the macroscopic world, Einstein's general relativity accurately explains gravity, the motion of planets, and the behavior of space-time. In the microscopic world, quantum mechanics governs atoms, subatomic particles, and phenomena invisible to the human eye. Both work perfectly within their domains, but there's a problem. They don't understand each other. And the black hole is where this rivalry reaches its peak. According to relativity, anything that crosses the event horizon is swallowed up forever. There is no going back. Information is lost. But in quantum mechanics, this is impossible. Information, no matter how fragmented, cannot be destroyed. This creates a paradox. If both theories are correct, and everything indicates that they are, then something is missing. Something that is not yet understood. This impasse has generated decades of debate, theoretical experiments, and even public fights between renowned physicists. The central question is, what happens to information when it enters a black hole? Does it disappear? Is it encoded in some way? Or does it escape through paths that we do not yet know? No answer is definitive, and each hypothesis opens doors to new possibilities about the structure of the universe. Stephen Hawking tried to resolve this tension by proposing that black holes are not actually so black after all, that they can release information, little by little, through radiation. But this raises another question. Would this information, when it comes out, still be recognizable? Or would it be like trying to put together a jigsaw puzzle without knowing the final image? Now tell me, if these two theories are at war, which side do you think is closer to the truth? Do you believe that information is really lost or hidden from our understanding? Comment below and share your theory with the community. Your insight could spark a new discussion about the limits of physics. There is something in this conflict that still escapes calculations and formulas. Something that may be hidden not in the equations, but in the very behavior of the black hole over time. And that is where things begin to evaporate, literally. In 1974, Stephen Hawking presented one of the most disturbing ideas in modern physics. Black holes are not eternal. They emit radiation. This process, now known as Hawking radiation, does not come from inside the black hole, but from the interaction between the event horizon and the surrounding quantum vacuum. According to the theory, pairs of particles spontaneously appear near the horizon. One falls in, the other escapes. The result? Loss of energy. And loss of energy means loss of mass. Over time, this process causes the black hole to shrink. Slowly, it evaporates at an imperceptible rate in giant black holes, but it is real. In billions or trillions of years, they could disappear completely. But if a black hole disappears, what happens to everything it has swallowed? This is the new dilemma. If Hawking radiation carries no information about what fell into the hole, then the information has been destroyed, something that contradicts basic principles of physics. On the other hand, if the radiation loads this information in an encoded form, so it is not random, it would, in practice, be a type of encrypted message. This possibility has transformed the way scientists think about black holes. The surface of the horizon may contain traces of what fell there, rearranged in patterns imperceptible to our current technology, like a safe that slowly releases clues, drop by drop, over cosmic eons. physics has not yet been able to decipher. Whether this radiation retains real traces of information or simply masks the loss with a statistical illusion. But if it is indeed encoded, we will be faced with something extraordinary. Black holes like cosmic libraries, slowly burning out, but leaving traces of what they have absorbed. What if these escaping particles are the only silent witnesses to everything that has ever fallen inside? Perhaps the universe is handing us fragments of a story we have yet to learn to read. In a universe where space can be curved and time distorted, the idea of a tunnel between distant points is no longer fiction. Relativity allows, mathematically, the existence of so-called wormholes. They would be cosmic shortcuts connecting extreme regions of space-time, or even alternative realities. Now imagine the black hole not as an absolute end, but as the entrance to this tunnel. A deformed passage that, instead of destroying, redirects. To where? Maybe to the other side of the universe, maybe to another universe entirely. The problem is, going through it would mean withstanding forces beyond any human limit. But in theory, exotic structures could stabilize this tunnel. Something like negative matter, as yet unproven. For some physicists, the very existence of black holes suggests that the multiverse may be more than just speculation. Each black hole would be like a gateway, holding the keys to an expansion that escapes our linear understanding of time and space. What if one universe could generate another from the gravitational collapse of a star? A black hole, in that case, would be the origin of a new Big Bang. And everything would begin again, but on a different plane. These ideas challenge everything we consider real, and this brings with it an inevitable discomfort. Perhaps what we call the universe is not unique, and what exists beyond our cosmic bubble is watching us right now. So leave your like, because it's a sign that you're among those who question, those who see beyond the obvious. If you realize the impact of these theories and value content that challenges certainties, your like shows the algorithm and the world that this type of knowledge needs to continue to be spread. But even with all these theories about portals and parallel realities, a more direct and perplexing question remains. What if we are trapped inside a black hole and we don't realize it yet? There is no escape. Once you pass the event horizon, the point of no return, everything that happens inside is sealed off from the rest of the universe. But what would you feel? What would you see? The answer depends on your perspective. To someone watching from the outside, you would appear frozen, static, trapped on the edge of the black hole for all eternity. But to you, the experience would be completely different. Extreme gravity would cause your body to be stretched vertically and compressed horizontally in a process called spaghettification. Your feet, which are closest to the singularity, would experience a much greater force than your head. Your body would elongate grotesquely until it was torn apart at the atomic level. No pain would be felt. Your nervous system would be destroyed before that could happen. The light around you would bend and fade until it disappeared completely. Time as you know it would cease to exist. You would be falling toward a point where past and future lose their meaning. No radio signal, no scream, nothing escapes. But is this really the end? Some theories suggest that in that final split second, something unprecedented happens. Space-time bends in such a way that your consciousness, or at least the information that makes you up, could be preserved. Not as matter, but as data, as patterns. The singularity would not destroy, but transform. Falling into a black hole would not only be a tragic end, but a transition to a state we do not understand. And this raises an inevitable question. What if there are already forms of consciousness trapped inside, trying to communicate, waiting for a form of decoding that science has not yet discovered? Stephen Hawking's proposal wasn't just bold, it challenge the very fabric of modern physics. If Hawking radiation exists and black holes really do evaporate over time, it implies that information once thought lost may be somehow preserved. This breaks one of the oldest principles of thermodynamics and forces science to look at the universe in a new light. Confirming this theory would pave the way for something physicists have been seeking for more than a century: the unification of Einstein's general relativity and quantum mechanics. To date, these two descriptions of the world work brilliantly, but they cannot coexist. Black holes are the only place where the two meet and clash. Resolving this impasse would be like finding the ultimate equation, the key to understanding the very fabric of the cosmos. But there is more. If information really does escape destruction, then the universe is indeed a coherent, complete system in which nothing is lost. This implies that there is a code, a fundamental pattern governing everything from the smallest particle to the largest galactic clusters. Perhaps what we call reality is just a superficial expression of something much deeper, a language that has not yet been deciphered. That's why this topic goes far beyond a theoretical experiment. It's about how we understand the beginning, the end, and the structure of everything that exists. And if Hawking is right, it doesn't just change science, it changes humanity's role in the universe. You need to send this video right now to that friend who loves the mysteries of the universe. Let's spread this discussion throughout the cosmos. But what if the error is at the starting point? What if everything we think we know about black holes is just a shadow of what really lies behind them? What lies inside a black hole may never be seen by any telescope. No lens, no matter how advanced, can penetrate the limits imposed by the universe itself. But that doesn't mean the answer is beyond our reach. Perhaps it lies exactly where it has always been, within our ability to question, to doubt, to construct hypotheses that defy known logic. Hawking didn't just defy the laws of physics, he expanded the limits of scientific imagination. This uneasiness we feel when faced with a black hole is the same impulse that took us to the moon, that led us to interplanetary probes, that leads us today to think about the existence of multiverses. The unknown is not the end of knowledge, it is its fuel. And when we view emptiness not as absence, but as possibility, we open space for something new, something that perhaps cannot be revealed with formulas, but with ideas. And that's where you come in. What crazy hypothesis about the universe has ever crossed your mind? Write in the comments. The most intriguing theories could become videos here on the channel, so let your creativity run wild. It may be unlikely, paradoxical, or even impossible, but it all starts with a question. Now, if you are here, it is because you feel that this type of content takes you further. So, activate the bell now and subscribe to the channel. Being part of this is more than just watching videos. It's connecting with discoveries that defy time, space, and everything we call reality. Here, each episode ignites a new spark of curiosity, and the next one could be the one that completely changes the way you see the universe. Click on the video that appears on your screen. There is a hidden idea behind it, and you are about to discover something that has not yet been explained, but needs to be understood.